Hello everyone, my name is Shadwin Raj and I am from DEP1A and my matrix number is 09 DEP22F1030. So today I'm gonna present about the vector. Vectors. Vectors in maths are objects which have both magnitude and direction. Magnitude defines the size of the vector. It is represented by a line with an arrow where the length of the line is the magnitude of the vector and the arrow shows the direction. It is also known as Euclidean vector or geometric vector or spatial vector or simply vector. Two vectors are said to equal if their magnitude and direction are the same. It plays an important role in mathematics, physics, as well as in engineering. According to vector algebra, a vector can be added to another vector head to tail. The order of the addition of the two vectors does not matter because the result will be the same. Check clause of the addition for more details. So now we're going to see the examples of vector. The most common example of the vector are velocity, acceleration, force, increase or decrease in temperature, and etc. All these quantities have directions and magnitude both. Therefore, it is necessary to calculate them in their vector form. Also, speed is a quantity that has magnitude but no direction. This is the basic difference between the speed and velocity. Vector notation. As we know already, a vector has both magnitude and direction. In the above figure, the length of the line AB is the magnitude and the head of the arrow points towards to the direction. So now we're going to see the examples of vector. The most common example of the vector are velocity, acceleration, force, increase or decrease in temperature, and etc. All these quantities have directions and magnitude both. Therefore, it is necessary to calculate them in their vector form. Also, speed is a quantity that has magnitude but no direction. This is the basic difference between the speed and velocity. Vector notation. As we know already, a vector has both magnitude and direction. In the above figure, the length of the line AB is the magnitude and the head of the arrow points towards to the direction. A magnitude of a vector. The magnitude of a vector is shown the vertical lines on both the sides of the given vector, modulus A. It represents the length of the vector. Mathematically, the magnitude of the vector is calculated by the help of Pythagoras theorem. For an example, modulus A equal to square root bracket x2 plus y2 close the bracket and it vector. A unit vector has a length or magnitude equal to 1, which is basically used to show the direction of any vector. A unit vector is equal to the ratio of a vector and its magnitude. Symbolically, it is represented by a cap or hat. If a is vector or arbitrary length and its magnitude is modulus A, then the unit vector is given by an example. See the example. It is also known as normalizing a vector. Thank you. So let's see the zero vector. A vector with zero magnitude is called a zero vector. The coordinates of zero vector are given by 0, 0, 0, and it usually represented by 0 with an arrow at the top or just 0. The sum of any vector with zero vector is equal to the vector itself. For an example, if A is any vector, then 0 plus A equal to A. Take a quick note. There is a no unit vector for zero vector and it cannot be normalized. So now operations on vector. In maths, we have learned the different operations we perform on numbers. Let us learn here the vector operations such as addition, subtraction, multiplication on vector. Addition of vectors. The two vectors A and B can be added giving the sum to be A plus B. This is requires joining them to head tail. We can translate the vector B till its tail meets the head of A. The line segment that is directed from the tail of a vector A to the head of vector B is that vector A plus B. Characteristics of vector math addition. Communicative law. The order of addition does not matter. For example, A plus B is equal to B plus A. Associative law. The sum of three vectors has nothing to do with which pair of the vectors are added to at the beginning. For an example, bracket A plus B plus C is equal to A plus bracket B plus C. Subtraction of vectors. Before going to the operation, it is necessary to know about the reverse vector minus A. A reverse vector minus A, which is opposite of A, has a similar magnitude as A but pointed in the opposite direction. First, we find the reverse vector, then add them as the usual addition, such as if we want to find vector B minus A, then B minus A equal to B plus bracket minus A. Scalar multiplication of vectors. Multiplication of a vector by a scalar quantity is called scaling. In this type of multiplication, only the magnitude of a vector is changed, not the direction. For an example, minus s a plus b equal to sa plus sb. Minus s plus t equal to sa plus ta. Minus a.1 equal to a and minus a.0 equal to 0. So minus a point negative 1 equal to negative a. Scalar triple product. The scalar triple product, also called a box product or mixed triple product of three vectors, say a, b and c, is given by a times b times c. Since it involves dot product and evaluates single value, therefore stated as the scalar product, it is also denoted by ABC. ABC in bracket equal to A times B times C. The major application of the scalar triple product can be seen while determining the volume of a parallel pipe, which is equal to the absolute value of A times B times C in modulus, where A, B, and C are the vectors denoting the sides of a parallel pipe respectively. Hence, volume of parallel pipe is C at the below. Thank you. Vector multiplication. Basically, there are two types of vector multiplication. First, cross product. The cross product of two vectors results in a vector quantity. It is represented by a cross sign between two vectors. For an example, A times B. The mathematical value of a cross product is A times B equal to modulus A modulus B sin theta n, where modulus A is the magnitude of vector A and modulus B is the magnitude of vector B. The theta is the angle between two vectors A and B. Dot product of vectors. The dot product two vectors always results in a scalar quantity. For an example, it has only magnitude and no direction. It is represented by a dot in between two vectors. A dot B equal to A dot. A dot B equal to modulus A modulus B cos theta. The mathematical value of the dot product is given as the below. Finally, components of vectors, horizontal and vertical. There are two components of vector in the x minus y plane. First, horizontal component, second is vertical component. Breaking a vector into its x and y components in the vector space is the most common way for solving vectors. A vector A is inclined with horizontal having an angle equal to theta. This given vector A can be broken down into two components, for example AX and AY. The component AX is called horizontal component whose value is cos theta. The component AY is called a vertical component whose value is a sin theta. Thank you.